Hey everyone, welcome back to the channel. Today we're tackling a huge question in software architecture. How do applications actually talk to each other? Think of it this way. Imagine you're at a busy airport. Flights are taking off, passengers are boarding, luggage is moving everywhere. None of this chaos would work without one thing: communication. And just like that airport, our software systems depend on clear, reliable communication. In this video, we'll break down the main ways applications and services connect, from APIs and messaging queues to event-driven systems and even file sharing, with simple analogies and real-world tech examples. By the end, you'll know exactly which method to use and when. Let's get into it. First, the simplest method: direct communication. Think of this like calling your friend on the phone. One application sends a request, the other answers immediately. This is typically done through APIs, REST, GraphQL, or gRPC. It's straightforward. But just like phone calls, both parties must be available at the same time. REST APIs use HTTP verbs like get, post, put, and delete to exchange JSON or XML. For GraphQL, clients request exactly the data they need from a single endpoint. gRPC uses a high-performance binary protocol called protocol buffers, though commonly known as protobuf, to enable fast and efficient service-to-service communication. But what if your friend is busy? Instead of calling, you could leave them a voicemail. That's how asynchronous messaging works. Services drop messages into a queue, like RabbitMQ, Kafka, or AWS SQS, and the receiving service processes them later. This method reduces wait time and improves system resilience. Message brokers like RabbitMQ, ActiveMQ queue up messages for consumers. Kafka is a distributed event streaming platform designed to handle high-volume, real-time data. AWS SQS Azure Service Bus are cloud-managed queues that let services talk to each other without being directly connected. This decoupling makes your system more reliable, scalable, and easier to maintain. Now imagine a group chat. You post one message and everyone subscribed can see it instantly. That's event-driven communication. Services publish events like order placed or payment completed, and any interested service reacts. It's powerful for building scalable, loosely coupled systems. The publish-a-subscribe pub-sub model lets one service send an event that multiple subscribers can consume independently. Platforms like Kafka, AWS SNS, and Google Pub-Sub broadcast these events to many consumers in real time. Serverless triggers such as AWS Lambda or Azure Functions can automatically react to these events, making workflows event-driven and effortless. Sometimes services communicate by reading and writing to the same database. But this is like sharing one diary among friends. It doesn't take long before things get messy. Conflicts arise, data gets corrupted, and performance takes a hit. Here's how it works. Services access the same database tables or schemas, relying on relational databases like MySQL, PostgreSQL, or Oracle, or NoSQL databases like MongoDB. While this method is generally avoided and discouraged in microservices, you'll still see it in monolithic or legacy systems. Another method, file exchange. Think of it like passing notes in class. Here's how it works. Applications share data using files like CSV, XML, or JSON, often dropped into shared storage such as FTP, SFTP servers, or cloud storage like AWS S3, Azure Blob, or GCP cloud storage. Flat files are exported from one system and imported into another, making this approach common in batch processing or when working with older systems. It works, but it's slower and less interactive compared to APIs or messaging. So which method should you choose? It depends. Need real-time synchronous interaction? Use APIs. Handling heavy workloads, delays, and async processing? Use messaging. Want scalable reactions to events? Use event-driven architecture. Sharing large data dumps or batch jobs? Use files, but with caution. It's generally best to steer clear of shared databases unless absolutely necessary. At the end of the day, communication makes or breaks your system's reliability and scalability. Just like people, applications need the right channel at the right time. So when you design your next system, ask yourself, do my services need a phone call, a voicemail, a group chat, or just a note passed under the desk? Thanks for making it this far in the video. If you found this helpful, don't forget to hit that like button, drop a comment with your thoughts or questions, and of course, subscribe for more deep dives on software engineering and system design. Until next time, happy coding.